First, we are going to take a look at the ways that window coverings can reduce heat flow. When the temperature outside is different from the temperature inside, heat travels in and out of the rooms through windows. Heat flow through windows can be especially dramatic in the winter, when the temperature difference between the inside and outside may be greater than 70 degrees. When we add insulating window coverings, we reduce this flow of heat. We're going to take a look at 3 types of heat flow: conduction, convection, and radiation, and explore how each of them can be controlled through window coverings. Let's take a closer look at a window in this room to see conduction in action. When warm air comes in contact with a cold pane of glass, the glass molecules on that surface are excited by the heat and begin to move more rapidly. These rapidly moving molecules interact with slower moving molecules, transferring some of their heat. This is called conduction. Here you can see that the heat from the warm air is quickly transferred through the glass to the outside of the pane. Glass is a good conductor of heat, so much more heat is lost through the windows than through the walls. Now, click any window in the room to lower the shades. With high-quality insulating shades lowered over the windows, the air pockets in the shades act as insulation to reduce contact between the cold windows and the warm air. This slows the transfer of heat through the windows and increases the energy efficiency of heating the room. Now, let's take a look at convection. Cool air is denser than warm air, so it tends to sink towards the floor. This causes the warm air in the room to rise and float on the cooler air. However, when this warmer air touches the cold window pane, it cools and sinks. This process, called convection, creates air currents to constantly move warmer air against the cooler glass. Even with airtight windows, a room can seem drafty because of these airflows. Now, click on any window in this room to lower the shades. By covering windows, you are reducing the amount of warm air that comes in contact with the cold window panes. Since there is less cool air sinking, this reduces the air currents, making the room feel less drafty. Reducing the air currents also means that less heat is moved towards and transferred through the windows. All of this means that covering the windows both makes the room feel more comfortable and saves energy. Finally, let's take a look at the effects of radiant heat loss. All objects give off and receive heat in the form of infrared waves. Hot objects emit more infrared waves than cold objects, and this imbalance results in heat transfer. For example, if you're in a warm room on a cold winter day and a nearby window is uncovered, you will lose radiant heat on the side of your body facing the window and feel uncomfortable. Now, click any window in this room to lower the shades. The insulated shade is warmer than the cold window pane, so it emits more radiant heat, making people in the room feel warmer and more comfortable.